Stefano.
Good
Stefano.
morning, Alexis. You doing?
I'm good. I'm good.
Okay, let's start this again. So this is like the second episode from the RLM series. So let's start where we were stopping the last time. So last time we were discussing about that a lot of people is doing implementation of RLM in the Solvit community. And today we're gonna take a look at the very first one, the one from Marius. It's coming like in, I don't know, November 2025, like few after the original like blog post was published, even before the paper that comes at the end of the year. Okay, we're going to take a look initially at Marius' original like blog post, the dialogue, and this is the one. And as usual, I clone it locally and I start like reproducing all the thing. And again, it's interesting because Marius started this with the idea of creating a plan, and his plan is like taking the original blog post and trying to implement that thing using Lisette. Lisette is the answer AI wrapper around like Light LLM that implement the same original Claudette idea with like Light LLM syntax. And so let's jump to the code. So I will try to take it like a quick look at what Marius did here. So he tried to take a look at the blog post. It's important then to solve it. Doing that is like extracting some interesting stuff and it start playing around with the Lisette and trying to say the basic building blocks, the basic components, like typical solve it approach to bring something small, test it out, see how it works. Then it start like going to the shell. So you want to use like as a REPL, the get shell. That's another like tool SM thing. And he's playing around with this and he's starting to understand like all the basic concept that you see on the paper. So the idea that the shell has an NS stands for namespace, and you can create a new variable because the namespace in the shell is simply a dictionary, and you can add an item into a dictionary and give it the meaning. So in this moment, it is injecting the context of like this text here as the context variable in the environment that the language model we use for the RLM. So he's really testing all the basic bits of all of this. Then he's creating the additional function for the.
Just to point out the super obvious, when you say shell, you mean a Python shell.
Yes, it's like the equivalent
Okay.
on a REPL. So you can
So it's like
execute.
we've created another Python
Yes,
interpreter inside that object, and we can interact with that object as if we were running code on a separate Python terminal, but instead it's like through the object interface. Is that
exactly,
right?
exactly.
Okay.
So look at this.
Just
This is
wanted
the
to confirm, clarify.
look at this. This is the LLM function. He created the shell. SH is this object shell that he used the create shell to make it. Now is assigning to this shell object, to this new REPL, this function, and is actually executing code, is evaluating within that REPL the execution of the function that he just made. So it's really testing out what is happening. Okay. So long story short, it combine and create all the small pieces. And at the end of the day, it's like wrapping down everything into a final class and like testing this in various different conditions. So this is the original like notebook. And what I did is like grabbing from now on, from RLM on, all the good part of the code that lead to a complete implementation that uses Lisette and tool SM shell, the get shell thing, to make an RLM implementation using these two things. And interesting stuff is that aside from the system prompt, okay, all the code you need to make an RLM with Lisette is all this. All this is only this is the code that you need to do that. On top of this, Marius making very interesting stuff. You find a way like to pretty print the history of what was happening. And so when like, okay, he's testing the things here. Okay, RLM, you instantiate this class, you give it the context. Okay. And what is the secret? This is the secret. And interesting stuff is that Lisette has this H thing that contains all the history of the messages. And he create this function that prints as a nice markdown. What is the history of the RLM? Is this Lisette chat. And so interesting stuff. This is what's happening. What is the secret? This is our prompt. Assistant is trying to make function is executing something, is making a mistake. Oh, I need to correct, to make it something different. And doing again is executing code till it's going to get to the secret. He's here testing the basic thing he just made, and then he
Sorry,
making.
sorry, I didn't
Yeah.
understand that. So it sounded like you intend for there to be something significant about the fact that the assistant saw a secret, but I didn't understand what was significant. Can you say that? Can you go
Okay,
over
the
that
thing
again?
in this moment here, we're taking a look at how all the pieces come together with a very, very small context. This context is
Right.
is a single line. So it's obviously just as simple. Let me do some more complex stuff and you're gonna get to the point. Okay.
Okay.
So this is like the basic initial unit test of the thing. Let's do something more complex. This is from like original
Wait,
Marius.
no, no, wait, wait. If we don't understand the simple thing, why will we understand the complex thing?
Okay, so the reason why the language model make this kind of code is because
Yeah.
having to deal with the very, very small context. So the context in this case is this one here. This is a sample context. The secret is 1, 2, 3. So
Okay.
even just looking at this, you just solve it. The
So
problem here,
that's not just the content of the context. That's kind of the limit of the context window for this small
it is
model.
the whole context that the RLM will see and it operate. So it's
Oh,
so
okay, great.
small that is
Mm-hmm.
this example here was just meant to show you how the things connect. Okay,
Okay.
so this is super simple. Let's say a unit test of the thing.
Mm-hmm.
Uh, okay, let's do something more complex. The first one he do is the needle in the haystack test, and so he created this function that
Wait, wait,
generated.
wait, 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 wait. Why are we going to something again more complex? Because in the last episode we were talking about RLMs.
Yes.
We said a lot of things about what they weren't, right? Or at least we pointed out things that they were like, but were supposed to be different from, right? I kept like complaining, how is this different from, Claude code running a shell, or how is this different from subagents?
Okay.
And then the promise we gave everybody was that we were going to explain like what the hell RLMs are that's so special. And I think maybe that really simple example will explain it more
Yeah.
clearly than coming up with a more complicated example, because simple
Okay.
things are
I have a
easier, right?
couple examples. I added one more complicated example to the original Marius one. Let's take a look at the simple needle in the eye stack. Needle in the eye
Yeah,
stack.
just humor me. I'm a simple man, so I kind of need to understand the simple example before I understand the complex one.
Okay. Let me. How you want to proceed? You want to just come back to the simple one and then
Yeah,
go?
well, maybe we can go back to some of the questions we raised before. So if I
Yeah.
recall, I said, hey, how is this different from subagents? Those already exist. And hey, how is this different from maybe, what agentic tools already do when they use like shell scripts and whatnot? That already exists. And I think, you said, and I think the authors of the paper have said that there is something,
Yeah.
more fundamentally different going on. And to be honest, I didn't understand what it is. And to be honest, I still don't. But if it's right in front of us in this example, well, that's a gold mine. Let's see
Um,
it.
I'm not really sure this example really stretched the system to the point where you can see a difference. But
Okay.
yeah, at the end of the day, the abstraction that even like Alex says in the one of the video that he made initially, that like if you think that any problem can be considered a coding problem, and if you think that your disk, your file system is a sort of like the same thing as the memory or of a context variable, you're
Hmm.
sort of doing the same thing, but it is kind of the same approach, not exactly the same thing. In RLM, you cannot modify the context. You only like just looking at it. I don't remember if, yeah, maybe you can modify, but I don't know. Maybe it's a slightly different thing. And I want to just taking a look at some real implementation to get the feeling of how the things works. I
Okay.
think
Okay.
that like
Yeah,
using
maybe a more.
something and making even use of something usually give me good intuition of what something is, what
Okay.
it
Well, let's
isn't.
look at the next one. If you think it'll be helpful, let's look.
Yeah, so like this is what's super simple, just proving that the print works, that everything works. And so needle in the haystack, that's the typical problem, simple one that you can find all the metric. And so here we want to say if a system can do good performance on needle in the haystack. So it's a testing with 100,000 lines. That is actually a lot of tokens, 650 thousand token about. And so now we are asking this. So I'm looking for a magic number. What is it?
Hmm.
And when you do the print, interesting stuff about the print, they're going to show you what is happening. So I'm looking for the magic number. What is it? A system is making some code to do this. It's trying to make the understanding. And interesting stuff is that it prints the output, and the output will be the result of the print will be the result of the tool. So you have some code that the executed, and the print is something that gets to the model to reason about that. So what the real model sees is going to be like this print output that happening from the code that has just been executed. And then things go on, and the system try it again, and eventually is going to find the number. Okay. Magic number is like this one. And in our initial implementation, this was the same magic number. Okay. So
Okay.
it does. We just proven that GPT-5 Nano that don't have like such a big context is able to deal with this kind of thing. Okay.
Okay.
Wait,
So,
this is the simple stuff. So
okay. Okay.
the
Good. All right.
system writes down code, print
Mhm.
out stuff, and do the thing.
Right. So
In this one,
even with a small context window, if it can do tool calling, it can handle a large quantity of
it
data. Got it.
what happening here is to me is more similar to a code interpreter than it's a kind of code interpreter that can receive the state of the chat as an input and give the
Sure.
answer because it
It's
didn't
literally
really
that.
do any recursion here.
Yeah. Yeah. It's literally that. It just used a code
Yeah,
interpreter to
but
interpret Python. Okay.
we need to go fast. I'm not sure we can jump to the second topic because we go
Okay.
at 12 minutes now. So and this was like the first thing I think it's interesting. Okay.
Hmm.
And then the second one that's maybe something that I'm not going to explain to you why this is happening, but it's like interesting to see what is the next problem I try to pitch to the machine. Oh, this is like a simple context manager that try to evaluate how much it costs to execute a light LLM function. I did this in an old notebook that I did in the past. And so what I make here, I created a new context, taking the Iris Setosa dataset from like the description from Kaggle, this description, and I take the Iris Setosa dataset and I create a function that creates a markdown that contains slam into the markdown a table and a description of what is Iris Setosa. Okay, so like
Hmm.
pretending this is a document with like all this information. And so it's like 150 rows of 5 columns, kind of a lot of data. And if you ask, can you compute the average length by species? Species is like the last one, is the
Hmm.
latest one. If you ask this thing to a normal language model, it will sure end up with the wrong answer because it like computing in his mind is not really using something unless you give the
Hmm.
code interpreter stuff like that. So eventually the system answers in the proper way. Interesting stuff is what happening behind the scene is make some code to try to extract by the context the things and compute all the things on his own. It first inspect what's happening, really making the code, computing all the stuff, and at the end of the day, printing as a JSON. It's a
Hmm.
fun because he uses structured output, even if I don't ask for that, and give me the right answer. And if you take a look at the answer here, okay, this answer is actually the right one. I make the compute to be sure, like Setosa 506 1462. So it really solved a thing. And then, like, I always speak with friends that say, I just upload an Excel file to ChatGPT and ask to do some kind of computation, and it really failed. And I say, okay, this is not the right thing to do with ChatGPT. Maybe sometimes it works with the code interpreter, but not always. With a system like this, you're free to make this kind of question.
Okay, but how is this system different from just any system where you say that the AI is able to make tool calls and those tool calls include running code?
For these kind of problem, it's not that different from
Okay.
exactly the code interpreter. We need to find more challenging problem. And I even see this maybe in some discussion, Alex say the same thing that you need to stress the system with the right question to let the system use the recursion in these own things.
Okay, so the recursion, maybe that's the point that I'm not understanding. Because
Yeah,
so far what I've seen is this is nice notebook and it seems to be a nice example of showing how to use the the kind of shell function to
yeah,
create and manage a Python subshell and the tools LM function to provide tools that are usable by the language model and maybe to install tools in the subshell, if I understood what was happening right.
Yes, you're
Okay.
injecting
So
new
so
functions
that
into.
so that's what I saw. Um, but I still didn't see anything recursive there. Everything I saw could be described as I have a language model and it's able to make tools. And you point out the tools can be helpful. If the input is larger than the context window, then I can use tools to process a larger input. Okay, understood. I still don't see what's special about recursive LM. Again, I haven't read it carefully enough, so I hope I'm not wasting people's time here. But it seems like a lot of other people are confused about this because I noticed that the authors of the blog post seem to be repeatedly trying to emphasize what's distinctive. So they believe there's something distinctive, but they're having trouble communicating it, including to me. Um, do you know what it is?
In this moment, I try like my intuition is that the implementation that I saw are kind of different from what they claiming to do in the paper. So this like
Okay.
everything is in this variable and your system will manipulate this variable. One of the things that I noticed is this one. Look at this more complex question. We're out of time, but let me do this.
Okay.
Make a complete EDA. Important. Do not use the data in the context and avoid plotting charts because the system was trying to import the Setosa data set in a different way. So
Okay.
we're giving the system a very complex task, make an EDA and
What is an EDA?
exploratory data analysis. Sorry.
Okay, cool.
It's
Exploratory
like
data
when you
analysis. Got it.
analyze
Got
a
it. Yep.
data set, okay,
I get
make
it.
an
Sure.
EDA. I task him to do this complex stuff. And it comes
Yep.
out with a pretty long description of stuff. And let us do what is happening behind the scene. Is trying to do a bunch of stuff. Okay. Is calling some Python, sometimes makes mistakes, correcting his own mistakes, and going on with this, inspecting. At the end of the day, it's like make a PCA, make some correlation coefficient stuff, and give it some explanation what he's doing. But let me get to the point. A thing that I notice is that the code is always trying to recompute the same table, reprocess the same rows all the time. It's not understanding that the best thing to do is like creating a data frame, reading and separating the text from the things, extracting, making a new local variable in the REPL that is df, and making this the first time and using this df to make all the other computation. We human, when we do something like this, we first parse the data, we clean up the things, we transform the text into some higher valuable structured data like the data frame,
Mhm.
and then we operate on the data frame. So one thing that I clearly see here is that maybe it's just prompting, but I read the prompt. It seems like it tried to push the model to do new variables, new things. But to me, and this is an interesting stuff that comes into the paper, there is a huge opportunity in teaching during the training to this system to take advantage of this new approach of recursion. That when the model
Yeah, you did it again. Like, what is the new approach of recursion? Can we say
it,
what it is?
the idea that the language model can always access to a REPL to make complicated and recursive stuff.
Okay,
That is
so
a
that,
thing. I'm
yeah,
seeing clearly here. I'm clearly
yeah.
seeing here that even with the prompt, the
Hmm.
model is not trying to do something like that. And uh, again, this is just a feeling of this initial
Okay,
exploration, reviewing this stuff, but it
right.
seems
So
that
clearly, I need to do more homework to understand it better. But let me tell you where I sit right now. Um, it seems to me that everything that you've shown could be summarized less grandly by saying the model can make tool calls, and in particular, it can make tool calls where it provides a programming language to be evaluated. So it's not just a single function, it's a more general model can author programs. And then you're also pointing out things like, hey, if you look at what the model does, it's kind of stupid about it because it doesn't realize that when it's making tool calls that are evaluations of code, that the code is evaluated in such a way that state maybe is preserved from one tool call to the other.
is
So the
reasonably
model,
stateless. It's not reasonably stateful. It didn't,
right.
it just
So,
communicating
right.
with the next thing only through what it prints and not what creating a new variable.
Yeah. So it's not remembering that a variable has been created and needs to get reused. Um, and then you're also saying, well, if you like trained the model better, it would do that, to which I agree.
I,
Um,
I think
but
it's an opportunity to make its
but
system
but
better at doing this.
but I think when you say quote unquote recursive stuff, you're revealing that you also don't really understand what is the special recursion thing that is supposed to be special about recursive language models. Um,
Even in this case, more complicated, the system didn't call the inner LLM. Really, I saw this in some of the
yeah. So again, like
description.
if
I don't know if
inner
the problem is easy or something like that.
if inner LLM just means a subagent, then it's not
Yes.
special, and then I don't understand why it gets a special name. So I think where I stand with all this is I need to read it more carefully. I hope we're not wasting people's time with us not understanding it. But I also think it's easy to get confused about. So hopefully it's reasonable to be confused and to move slowly at it.
Yeah.
But the thing I take away is that there are different notions of interpretation. You can think about uh, a LLM model doing its inferencing as a kind of interpretation process, like you give a prompt and the prediction is the output. And then you can think of a Python interpreter as doing a kind of interpretation. You give code and then the output of the code is the code. Um, you can think of a single tool function as a kind of interpretation. Like I give you 1 and 2 and you give me back 3 because the tool does addition. And um, spawning a subagent is also a kind of interpretation. Like you give in the prompt and then you get the output kind of coming back as a function rather than coming back as a um, set of new auto-regressive outputs in the current execution environment. And what I'm taking away from this is if you zoom out or zoom in, if you squint, you can see there's like 3 or 4 or 5 different notions of interpretation and execution that are all at play here, but we have a somewhat muddled way of thinking about them. And therefore, certain kinds of things feel like a big step, or certain kind of things should be possible, but we don't make them easy. And probably what the RLM paper is about is they have identified some particular kind of interpretive capability, and they think that's qualitatively different from the other ones that exist, and they think it is very important in the kind of capabilities it provides. And all of that may be true, but I don't understand exactly what they're saying. And I also think that if you look at existing systems and squint carefully, you can see there's a bunch of different kinds of interpretations already there, which we don't talk about in that way.
Yeah.
And that does connect to my blog post, but we've run out of time, so we'll have to talk about it later.
Yeah, I was really pushing you toward that thing because I really think that your idea of composability, like the reason why, yeah, can you really pitch a few seconds about your blog post, or we're gonna like, yeah, I think it's
Yeah, so
really
I wrote a blog,
it
so I'll
really
give a few
connects
seconds,
very
but then I
well with
really
this.
do. Yeah. I wrote a blog post. We can talk about it later if it still seems relevant. Maybe it could fit into the discussion of RLMs. That would be a good way to wrap it up, a 3-part series. And my blog
Yeah,
post here is called Why Claude Code Won. Claude Code's a publicly released product. Solve it will win when it's publicly released, but it hasn't been publicly released yet. So far, why Claude Code won for now. And the point I make is that it uh, succeeded despite being very awkwardly a command line tool. But I think the real reason it succeeded is because it's a command line tool. Because by
I
being a
really, I
command line
really love
tool,
this comment. I really love this comment, and I really, you let me think a lot reading this kind of thing. It's
yeah. So the comment you're highlighting is a kind of a side box I have in the front saying that um, by being a command line tool, Code was idiomatically and naturally inclined to access other command line tools in the way it was built. In particular, it can access Bash. And because it can access Bash, not just individual tools like ls for listing files or diff for diffing files, but because it can access Bash, it has access to a whole programming environment with a lot of recomposable elements, and that's just very flexible and powerful, and that's where the Claude Code power comes from. But we got to go now, and let's have like RLMs part 3 next time, and maybe the right way to go into the depth of RLMs part 3 to figure out what's actually unique about RLMs versus what's just a complicated label for something we already know about is to like put it next to Claude Code using Bash and say, is Claude Code using Bash actually an RLM or is there something different? Is it useful to have this fancy word for it? I don't know the answers to those things, but we can try to talk about them next time.
yeah, okay. Let's see next time, and
Next
thank
time.
you, Alexis, for your time.
All right.
Bye.
Bye bye.
Bye bye.